Okay, question number 4. The last question of this tutorial 3 is about a system where now the stone is wheeling around horizontally. It's not like just sorry, it's vertically. Okay, sorry, this is my mistake. It's vertically. It's not horizontally like the question number 1. Okay, so it has a mass of 120 gram. So it's whirling vertically. Okay, with a radius of 80 cm at a constant speed of 4.0 meter per second. Now the question wants you to find the ratio between the tension at rod A and the tension at the rod B. Okay, so let's see how can we do something about that. Now let me call up my pen first. Okay, pen is coming up. So I redraw again the system here. Okay, now there is a stone over here. Sorry. Okay, sorry, there is a stone. There is a stone over here. Okay, there is another stone over here. Okay, so now there will be a tension TA. Okay, now there will be another tension at this part. Let's say it's TB. Okay, now don't forget that there will be a centripetal. So there will be a gravitational force pulling it down, which we call the mg. And here we also having the same. The direction of the gravitational force is the same as the tension force Tb. Okay, now at point at A. Okay, at A. Okay, so we know that there is no free lunch in this work. So do the centripetal force. So the centripetal force is equal to the difference between TA and mg. Okay, now look at here carefully. Okay, look at here carefully. So look at here carefully. Look at it. Okay, now you notice that I'm using TA to minus away the mg. So what does this physical meaning here? It means that the TA have a force larger than mg, so that it will still be connected as the system, as shown in system. Now what if mg minus TA? Okay, if mg is larger than TA, it means that the gravitational force is larger than the tension. Okay, now it means here the connection here will break. Okay, the connection will break, but in this system, no, it cannot be break. Okay, so that's why we have to use the difference between TA minus mg. Now let's go to B. Okay, at B, and we know that the centripetal force is provided by the plus of these two things. Agree? Okay, the plus of the TB and the gravitational force mg. Okay, okay, so because they are sharing the same directions, like okay, in the system as shown I have drawn here, they are sharing the same directions. Okay, so the question wants you to find the tension at A and the tension of B. Okay, the ratio. Okay, so very straightforward. I can get it as mg plus m. Now which one we have to choose? Mv square over r or ml square, ml omega square? So I will choose mv square over r because it's given my v equal to 4 meter per second divided by, now be careful here, is mv square over r minus mg. Okay, now I can cancel all the m away, so I can get v square over r minus plus g over v square over r minus g. Okay, now plug in everything they're giving you in the question. It should giving you the answers around 2.93. Okay, now this is a ratio. Ratio means that there will be no unit. Okay, now what is the physical meaning behind these questions? Okay, you can see TA is around 3 times larger than TB. Okay, so this means that at this point A, the tension that have it in A, the tension of this rod is larger. It's extremely larger, 3 times larger than the tension at B. Okay, so means that if this is not an ideal case, you will notice that this is a string. The string of this B will be go down a bit. Okay, now this is extra things I'm telling you now, and you will find it at some, I think, in the partial questions. Okay, the partial question asked before how to calculate the system where the string will be come down a bit. Okay, means that they will contract a bit at this part. Okay, at this part, at part B here, it will become smaller a bit. Okay, so that's it for the tutorial 3, the 4 questions that I've discussed. Thank you.